Alright, welcome back to the tutorial. For this video we're going to be going over making the actual Python game work on your computer. So to start we're going to open our three files, so we're going to navigate to wherever our thing is. We're going to open these three Python files that make up our game. You can close out of this one. So the structure of these files is we're going to have, this is our main entry point to the game, so we'll be running this file and it'll run our game. And these are class files, which is something I haven't introduced you to yet. So in the class we can have variables that belong to the class and functions that belong to the class, and then call those functions and access those variables through the class. So in an entry point in Python, I guess in files in general, you're going to have some sort of code at the top that should be telling readers what exactly it is doing, and then we're going to have some sort of import statements up here. So in this one we're actually importing Game Engine, which is our class here, so we're importing our class so that we can use it. And then these two are blocked out for now because the Pygame, so just Pygame we import over here, which is the library that makes it work on the computer, and Pygame SDL2 and this line here replace some parts of Pygame to make it work on the Android phone. And before I forget, we're going to go ahead and download Pygame. So you want to be here. If you Google Pygame and come to this download page, you'll get it. And we want Pygame for Python 2.7 and 32-bit, and that is this one right here. So we have 2.7 and Windows 32-bit. So click this and download it, and then once you download it you can just double click it, and as long as you don't have any other versions of Python installed on your computer, it'll automatically install Pygame to Anaconda. And if you do have other versions of Python installed, you have to be more cautious as to how you actually install it. So it installs to Anaconda for the version of Python that we want to use. Let's talk about this statement. Okay, so what this if statement here says is that if this is the main file, so if we're running from this location, or in this case, if it's the main Android thing, then we can run this block of code. So what we're going to do in this code is we're going to initialize an instance of the Game Engine class, and that is done. We can type any name, and in my case I'm just going to do GE equals Game Engine. So that's where this class is stored, so import Game Engine. And the class is called Game Engine as well. So GameEngine.GameEngine, and then this, because we don't require us to pass any parameters to initialize Game Engine. So now we have a instance of the class called Game Engine. Then we're going to run the function called GameLoop, which will handle the main loop of our game. And once that loop has terminated, we will call ge.quitGame. And that's it for this file. So the next file we're going to look at is our GameEngine.py. So this will handle the everything for the most part. So at the top of our file, we are going to have a bunch of variables for this class. So the first one is going to be screen size equals 500 by 500. And this is a type I haven't introduced you to yet. It's called a tuple. The tuple is designated by the parentheses. It's similar to a list, and it's accessed by the same way. So if we wanted to access this first one, we'd type screen size square bracket 0 square bracket to get that 500. We're going to set the background color equals 50, 50, 50. And these values are red, green, and blue. So the higher this number is, the more red, green, or blue it'll be. So all zeros is black, and all 255s is white. 255 is the highest value. It has to be an integer. Next we have caption equals simple Android games with a caption for your window. We're going to set a variable here. This is a boolean. It's going to ask whether we're done, and this variable will control if our game loop continues or not. So as long as it's false, it's going to continue. So the frames per second to be 30.0 to be the target frame rate. We're going to set the color of the ground to be white. We're going to set the color of our character to be red. And feel free to play with these once you have the game running to see what they're doing. We're going to set gravity to be equal to 9.81 times 10. If you are familiar with physics, 9.81 is the metric gravitational constant. And if we just use that, then we'd be saying that our pixel, each pixel would be 1 meter. And that is a little bit too zoomed out. So by saying this, we're effectively saying that each pixel is 10 centimeters instead. And it just makes it a little bit smoother. And you should play with this constant once you get the game working to see what it does. Next we have our object size. We set that as a default of 20. That's going to be the size of our character. And then we're going to make a list objects and just initialize that as being empty. And then we're going to get the current time. So this will happen when we make this class. Game time equals time.time. So we had to import the time library to call this function. That's just going to return a large integer number, which I can just show you over here. Import time. I think it's an int. Time.time. Nope, I was wrong. It's a float. So it's a very long number. This number started in like 1971 or something, and it's the amount of seconds since then. So yeah. And so, okay, that's all of our variables we're going to set up here. Now we are going to work on our initialization function. So this underscore underscore init underscore underscore is a default function. So this is going to get called when we do this right here. And in a class, Python requires that you pass the argument self to it. And we'll see how self works. It's basically just calling itself. It's kind of dumb, but so first we're going to initialize Pygame by typing pygame.init. Then we are going to change our resolution to be the resolution of our current screen, which is done with a couple lines. Size pygame.display.info. And then now we're going to change our screen size. So that's this variable up here. But now to access a class variable, we have to type self dot, and then whatever variable or function we want. So you can see Spider is kind of suggesting a bunch of things for me. We want screen size. We can go down here and then select and hit tab to autofill. So self.screenSize equals size.info.current width and size underscore info.current h. So it's the current width and height. Let's set a new variable there. So we didn't actually have to set this up here. Next, we're going to finish initializing the Pygame. And we're going to do that by typing pygame.display.set caption and use our caption. We're going to give Pygame a screen by typing self.screen. So you can see we're actually going to make a new variable for this class here, self.screen, that we didn't initialize up here. So if you wanted to, all these variables could happen in this initialization function. Screen equals pygame.display.set mode self.screen size. And then type this. I have no idea what this does, but the documentation says it should be there. Rect equals self.screen .get rect. One thing that you may or may not have noticed is that whenever we call a variable, it has no parentheses at the end, and whenever we're calling a function, it has these parentheses. Just a side note. And then we are going to add our character to the objects list. So in the game that I'm showing you, we have a list of objects, and technically we don't need that for this game, but I'm just going to do it to show you how it would work. So we're going to say self.objects.append to add a new object to the list, and then we're going to add our class game object, which I haven't gone through yet. So we're going to say go, because we imported game object as go. So we're making a new game object, and we're going to pass a bunch of variables into it. And the variables that we need are, in order, we need the screen that it should be going on, so self.screen. Then we need a list that is the position of our object. So we're going to have a list, and that list, we're going to start it in the middle of the screen. So we're going to say self.screen size divided by 2.0, so we don't get any wonky integer division shenanigans. And comma self.screen size divided by 2.0. And then we're going to give an initial velocity of 0.0, 0.0. So this is the x position and the y position, and this is the x and y velocity. We're going to give it a color, object color. I'm going to give it a size, self.object size. And that's it for that one. In the last line, we are going to set a floor height to be halfway up the screen. So we're going to say self.floor height equals self.screen size divided by right. 0. 1 divided by 2.0. So this right here will return, won't return a typo for this part, but it is wrong. So I'm going to show you why over here. So if we say size equals 500, comma 500, and then we say we have a array, which is a list that we're making, which is size divided by 2.0, comma size divided by 2.0. Oh, yeah, I didn't actually like that. So the reason it's doing that is because we have this full tuple here, and what we actually want is the first position and the second position, like that. So we're going to go ahead and edit that here. 0 and 1. And for this case, the y direction is 1s, and we want halfway up, which is y. So we're accessing the first, or the second spot, which is, yeah, 1. Okay, and that's all for the initialization function. Next, we're going to go over the event loop, which is right here. So the event loop, as this comment says, is going to handle key presses. So every time we push a key, it's going to get added to a list, and that list is going to, we're going to look at that list and see all the keys that happen and then do things based on it. So to get that list, we are going to make a for loop for event in pygame.event.get colon. We are going to go ahead and check if it's a left mouse click, and the Pygame SCL2 treats left mouse clicks as a button of touch on the screen. So that will work for our Android version as well. So we're going to type if event.type equals pygame.mouse button down, and event.button is 1. So I haven't shown you combining statements, but you can use the AND keyword or the OR keyword to have multiple statements in your if statement. And then if this is true, we're going to say self.objects 0, so that's the first element in our list, which is our character that we added up here. And then we're going to call the function jump. Then if we push the escape key, event.type equals pygame.key down, we are going to say, so the reason we're going to do it this way, event.key equals pygame.k escape. So the reason we're doing it this way, instead of having an AND like we had above, is that if the event type is not key down, and we try and call this thing on it, it's going to return an error. It's going to throw an exception, and then it's going to break. And so to avoid that, we're going to first check if it's a key down, and then check what type of key it is. So if it is true, we're going to, or if the escape button has been pushed, we're going to say self.done equals true. And if you looked through the Git page where you copy all this stuff from, you can see there's actually a full source file which has the completed source code for this game, and in there you will notice that there's a little bit more code here, and that handles if you push the back button on your Android phone, and we're going to leave that out for now. It's giving an error. What does it not like? So equals equals is a check for equivalency, and equals is a set variable. So if you have an equals here, when you need to have an equals equals, it's going to throw an error. Oh, same error here. Another tidbit about Spider is that this little asterisk here means that the file is not saved, and you need to save it. So you can hit Control S or this little floppy disk. Okay, and that's all for the event loop. Now we're going to go into update physics. So at the beginning we're going to set up our time step, so the time since the last calculation. Say new time equals time.time. Then we're going to say dt, which is our change in time, equals new time minus self.game time. And then we're going to set our self.game time to be equal to our new time, like so. So what this is doing is we're looking at our old time step and the time that we just got to get a change in time, and then we are should be neither setting our old time to be our new time. So for every object in our objects list, we're going to apply some physics on it so we can move around. So we're going to say for game object in self.objects, do some physics. So the equations are listed right here. We're now going to go through them and add them. So game object dot position 1, so that's y, equals game object dot position 0, so that's the old value. Sorry, we want 1 for the old value. Plus game object dot velocity. 1 times dt is our time step, plus 0.5 times self dot gravity times dt squared. Then I'm going to go ahead and add another one in case you guys want to try and make it move left and right. This will be the equation to make it move left or right if you give it a left or right velocity. So we'll say game object dot position 0 equals game object dot position 0 plus game object dot velocity 0 times dt. And it has no acceleration in the x direction, at least not from gravity, so we don't need that. Okay, for velocity, we'll say game object dot velocity 1 times game object dot velocity 1. This should not be a times, this should be an equals. Plus self dot gravity times dt. And if there's no gravity, then for the x direction, we're just saying the new velocity is the old velocity. So don't update that, or don't make another one for x position. And then we're going to make sure it doesn't go through the floor. We're going to do that by checking if game object dot position 1 is less than self.floor height, is greater than self.floor height. We're going to set main object.position 1 equals self.floor height. Like that, and we're going to set the velocity to be 0. Game object.velocity 1 equals self dot, not self dot, we're just going to say 0.0. Just like that. And that's everything for this function. So let's say right now there's nothing controlling if you can go off the screen, and if you wanted to control that, you would set it probably right here, and you start by saying something like else if, and then your condition for off the screen, and then what you want to do with it. Also, if you wanted to add right or left movements, you would add them right here. So you could say if event dot key equals pygame dot k right, let's say, and then tells it to do something. And yeah, it could also be an else if, either works. Okay, on to the main game loop. So in Pygame, how it works is we have a screen, and every time we have a frame, we're going to draw each object onto the frame, and then update the frame. And things stack, so if we drew the character and then the background, it would overwrite the character. So first we're going to set the background by saying self.screen.fill, and then the color we want. It's that simple. Then we're going to draw our floor. I'm going to say pygame.draw.line equal, and the inputs for this are going to be the screen we want to draw it on, the color, there we go, a tuple that has the starting location of our line. So it's going to be the very left side of the screen, so 0 and x, and the y is going to be halfway up the screen. So self.screen size 1 divided by 2.0. And we actually want to have it be down the screen another half the object size. Dot object size divided by 2.0. And we're actually going to use a plus to go down here, and to explain why takes a bit of explaining, so I'm going to draw real quick. Okay, so in our matrix, so we're going to have a matrix of pixels that represents our screen, right? And we're going to be counting up this way and then up this way, because that's how we read a paper. So our y-axis is going to be flipped when we're doing matrices. So to move down the page, we actually have to increase the row number. Yeah, so that's that. So we're going to move it down. Then we're going to have a second tuple that is the end of our screen. So we're going to have the full width of the screen dot screen size 0 for the full width, and we're going to have the exact same value for the y. I'm just going to copy this in. Oops. And then we're going to have, oh, that's the last argument. So just that. Now we have a floor. Now we want to check for handle button presses, and we made our function for that already, so we're just going to call it self.event loop. Then we're going to do our physics, self.update physics. Then we're going to draw all of our objects. To do that, we're going to make a little for loop for game objects in self.objects. We're going to call game object.draw. And that's a function we're going to make in a minute. And then we're going to finally update the entire screen. So Python.display.update. Alright, there you have it. That's most of our game. And then for the quit function, I'm going to do some fancy stuff so it quits properly. Pygame.display.quit, pygame.quit. And that's it. Okay, so we're going to move on to the game_object class. Okay, so for game_object, we have three classes, or three functions, sorry. So when we initialize it, we're going to have no variables for this one. So when we initialize it, we're actually going to pass a bunch of variables into it. The first one is going to be the screen we want to draw it on. The second one is going to be our position. We're actually going to have a default position of 0, 0. And if you remember, 0, 0 is going to be the top left of the screen from our matrix that we drew earlier. We are going to have a velocity equals 0, 0. We're going to have a color of black, and we're going to set a size of 20. So setting a default means you don't have to pass a parameter for this argument in to the function. And if you don't, it'll just pass, it'll just use the default. So let's say, for instance, we could do game go equals game object. We pass screen. So we could do position, vel, col, size, whatever. But if you don't want to pass all those in, let's say you want to skip position, then you have to say velocity equals myvel, etc. You can have any combination of those that you want in there. Okay, so now we're going to save all these inputted arguments into this class itself. And to do that, we're going to type self.screen equals screen. Just like that, but for all of them. Self.position equals position, self.velocity equals velocity, self.color equals color, self.size equals size. And then we're done. Okay. Now we're going to go ahead and draw the character on the screen, and we're just going to make it a square. So it's going to be pygame.draw.rectangle. And we're going to actually go and look up how to do this on the Pygame documentation. This is a good skill to learn. So we're going to just Google pygame.draw.rect. We're going to try and find the arguments. Okay, so we have a bunch of pygame.draw things, so you can look at line, circle, whatever. So we're going to go to rectangle, and we can see right here the arguments that we're passing in. So we're going to pass in a surface and a color, and we know what those are. So we're going to do self.screen and self.color. We don't know what a rectangle is, so we're going to go look up what a rectangle is by looking in the examples. Okay, so let's make this a little bit bigger. So we can see a bunch of examples from code, people drawing rectangles. We have, this is a screen and that's a color, and we have something that is a tuple that is 4 integers long. And so what these 4 tuples are, I'm just going to tell you. Let's see if I can remember correctly. We have the lower, or excuse me, the left side, and we have the bottom. So this right here is the left side, so the far left of the rectangle. This is the bottom of the rectangle. This is the width of the rectangle, and this is the height of the rectangle. So we're going to go ahead and make this tuple. We're going to say self.position 0, because it's x. We're going to say minus self.size divided by 2.0, because we want our position to be the middle of our box. Then we're going to say self.position 1. Actually, this is the top of our thing, not the bottom. Self.position 1, again, minus self.size, because remember size will go, size will move it in this, or minus will move it up the screen. Divided by 2.0, then we'll have our size, self.size, and self.size. And our last argument you saw on Pygame is that we had a width, and that's the line width. And we're just going to leave that blank. So that's it for that. And then for the jump, we're going to type self.velocity1 minus equals 200. So whenever this gets called, we're going to subtract 200 from the y value of our velocity. And at some point, I'd encourage you to try and make a double jump function. So as it is, we're just going to jump forever, but I encourage you to try and make just a double jump so you can't keep jumping. Okay, so that is the entirety of Pygame. We're now going to go ahead and try and run it and see how many typos I have. What's this one for? Undefined name size. It says size.info, it should be _info. Okay, so we're going to go ahead and try and run it. So you have to run it from main, make sure all the files are saved, and see what sort of bugs we get. So for you debugging, I tried to kind of go through as we're going through, say all the things that might be hangups, but for you debugging, you might just have to go to the full source that I provided and compare. I'll go through the errors that I get, and you can try and follow along. In general, the error is displayed kind of, it has a call stack. So this is where it happened in your thing. And then this is where that function was called from, and then where that was called from, and then where that was called from, etc., all the way up to the top of the list. And so for us, we can see it's in the file GameEngine.py and line 38 in the function init. And we can see just from this line right here that we misspelled display. So we're just going to go over here, I'm going to find display, and we're going to fix our typo. Go back to main, reset. I did the exact same thing in line 41. Brilliant. Okay, try it again. So you can see again, we just missed the little typo there. J and E are switched, so that's line 73. Game object. Okay, so you can see now this means it's running. We can click on this, and ooh, it's working. And let's test our button. So if we click, oh, it broke. So we expect it to jump, and it did not jump, so we hit escape, and it blows up. When this happens, you can try and hit the X button, and it'll just do this forever and won't really close. The fastest way to get out of it is to right-click in your console and hit quit. And it might say here something like failed to connect to kernel, or kernel died or something, restarting, and just keep doing that. It'll stop eventually, so don't worry about it. But by killing it, I didn't look at my error message, so I'm going to run it again and kill it. And what do we got going over here? We have game engine has no attribute objects again. Okay, so that's not good. So we're going to fix this before we kill it. This is on game engine line 55. Line 55, right here, self.objects.jump. Alright, now we're going to quit this and try and run it again. Alright, there we go. We can see it jumps and it comes down. We can click again and it'll go up. We can just launch it way off the screen and it'll eventually come down. There's no drag or anything, so it'll eventually fall very quickly. And let's test out the escape button. Yep, so that works too. Alright, so we now have a working game. Before we continue, or before you continue to the next video, I'd suggest playing with it. So you can play with this. You can change the size and color of your character. Don't tinker with it in here though. You can change the shape in here if you want, or the starting position. But you should change the colors from up here, change gravity and the size from here. And you can try and add left and right if you're ambitious. Sorry, that should be here. And maybe add double jumping, which would also be partially in here. Alright, so I'll see you in the next video.